Alright, we're graphing proportional relationships. So we're using graphs to figure out if they are proportional or non-proportional, like we did yesterday. We're just adding in graphs. So this should be somewhat of a review from graphing. Does anybody remember what this whole entire thing right here is called? Asia. A coordinate plane. Inside this coordinate plane, we have 4 quadrants. My y-axis and my x-axis divides it into 4 quadrants. If you remember, you count your quadrants counterclockwise. So you go 1, 2, 3, and 4. So you're going counterclockwise. Where that x and that y-axis meet, that is your origin, which is at the point 0, 0. So it should be easy to remember because origin starts with O and it's point 0, 0. Most of the time, your coordinate planes will always have your y-axis and your x-axis labeled with this little y and x. But if not, you need to remember that your horizontal line is your x and your vertical line is your y. Somebody tell me what this 1 is called. What's the name of that 1? X coordinate. So the 1 is called your x coordinate. What is the 2? Y coordinate. When you put the x coordinate and the y coordinate together, what is the whole thing called?
X, Y coordinates.
Ordered pair. The whole thing put together is called an ordered pair. That's what tells you where to plot your points, or how to plot your points. So at the bottom it tells us to graph 2, 3, and -3, -2. So if I'm graphing 2, 3, that tells me that my first number of 2, that's my x coordinate. So it's either going to go left or right because it's on my x axis. So since it's a positive, that means I'm going right 2. And then my 3 is positive, so that means I'm going up 3. And I'm plotting that point. If I want to plot -3, -2, they're both negative, so that means I'm going left 3 and down 2. And then it tells me to connect those points. So if I connect the points, describe what that is. A what?
Line.
A straight line. It is a straight line. So we are going to use lines to figure out whether relationships are proportional or not proportional. So flip over. It tells us another way to determine whether 2 quantities are proportional or not is to graph them on the coordinate plane. And if the graph of the 2 quantities is a straight line through the origin, then the 2 quantities are proportional. So if you graph quantities and they form a straight line and they also go through the origin, then it means that they are proportional. If it's a straight line but it does not go through the origin, it is not proportional. It has to go through the origin and it has to be a straight line. So both of the 2. Let's look at example 1. It says the slowest mammal on earth is the tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane. So the first thing that we need to do is we need to make a table. We are comparing or trying to see if the number of the feet that the sloth moves is proportional to the number of minutes. So distance and time. Okay. So my time is on top and my distance is on bottom. We know that if he goes 0 feet, he went or if he didn't climb at all, it's 0, 0. He didn't go anywhere, right? But it tells me that it moves at 6 feet per minute. So if he's traveling 6 feet, that's per 1 minute. Okay. So then if he goes for 2 feet or 2 minutes, he's going to travel 12 feet, and so on and so forth. The time is going to be my x, and distance is my y. So when I look at these two, that means that 0, 0 is my origin. That's going to become an ordered pair. 1, 6 is an ordered pair. 2, 12 is an ordered pair. 3, 18 and 4, 24. Those are all ordered pairs now. So that tells me that I can graph it on a coordinate plane. So when I do that, which it's already done for us, we plot all those points, 0, 0, 1, 6, 2, 12, and so forth. We connect the dots, and it forms a straight line, and it goes through the origin, 0, 0, right? So therefore, it's proportional. Time and distance that the sloth travels is proportional to each other because it passes through the origin and it's a straight line. Okay. Let's do A by ourselves. It says James earns $5 an hour babysitting. Determine whether the amount of money James earns babysitting is proportional to the number of hours he babysits by graphing on the coordinate plane. Explain. So what's the first thing that I need to do?
Make your,
Chart?
yeah.
Okay. So if we make a chart, what do you think is going to go on top?
$1 the hour. The hour. The time.
Okay, so we're, it already kind of gives us our graph with our X and Y labeled, right? So I know that my top is my X and my bottom is Y. So if I look at my X-axis, that's time. So this is going to be time in hours. And then my Y-axis is amount, or money. So it tells me that he earns $5 per hour, right? So it's obvious if he doesn't work, he's not going to make any money, right? So we start at 0, 0. But then if he works for 1 hour, he makes $5. What about if he works for 2 hours? How much money is he going to make? $10. What if he works for 3 hours?
15.
He's going to make $15. So these are my coordinates now. 0, 0, 1, 5. So that means I'm going over 1 and up 5. Over 2 and up 10. And over 3 and up 15. Then I want to actually connect all those points. So what do we think? Is it proportional or not proportional? Why? And?
It goes through the origin.
Good, because it's a straight line and it goes through the origin. It's proportional because it's a straight line that passes through the origin. 0, 0. Questions? All right, flip over. Let's look at example number 2. The cost of renting video games from Games Inc. is shown in the table. Determine whether the cost is proportional to the number of games rented. So they already gave me my table. So I know that these are my ordered pairs. 1, 3, 2, 5, 3, 7, and 4, 9. So if I want to graph those, like they've done for me, they've got 1, 3, 2, 5, 3, 7, and 4, 9. How did they know that 0, 1 was a point on that graph? What do you think? Because it wasn't in my table, right? 0, 1 wasn't given in my table. But what did we do to get from 3 to 5? We added 2. What about from 5 to 7? And from 7 to 9? Okay, so what if we added a 0 up here? How would I figure out the number that goes with 0? Subtract 2 from 3, which gives me what? 1. So that means that my point is 0, 1. That's how they got the 0, 1 right here. So, is that a straight line?
Yes.
But does it pass through the origin? No. It starts at 0, 1. So is it proportional or not proportional?
Not proportional.
It is not proportional. It does not pass through the origin. So it is not proportional. Another way that we could check it is like we learned yesterday. So I can make my ratios of 1/3 and 2/5 from my table, right? 1/3 and 2/5. Are they completely simplified? 1/3 and 2/5. Yes, you can't take them down any further. So that tells me that they are not equal to each other. 1/3 is not 2/5, so that tells me that it's not proportional. All right, so B, the table shows the number of calories an athlete burned per minute of exercise. Determine whether the number of calories burned is proportional to the number of minutes. So I've got my table. So now I just need to graph my ordered pairs, right? So that means I'm still starting at 0, 0. I'm going over 1 and up 4, over 2 and up 8, and then over 3 and up 13. Now if I connect my dots, what happens at that third point? Is it on my line? No. So what does that tell me? It's not proportional because that is not on my line. So if I were to connect these dots, I would have to stop right here, and then I would have to go back and connect those two dots, which would not make a straight line. Okay. Another way that I could figure it out, because if you didn't use a straight edge, you probably went ahead and connected them all and thought, oh, it's proportional, right? Okay. That's why it's important to use a straight line. You can use a piece of paper if you don't have a ruler, or anything with a straight edge. Or you can always go back and check and make sure if they really are proportional. I can make my ratios like we did yesterday. So my ratio of 1/4, or 1 and 4 is going to be 1/4. My ratio 2 and 8 is going to be 2 over 8. And then 3 over 13, right? Remember, to tell if they're proportional or not, you have to simplify them as far as you can. So can I simplify 2/8? To what?
1/4.
1/4. So I know that these two are equal to each other, right? But what about 3 over 13? Can I simplify that?
Nope.
No. So is 3 over 13 equal to 2/8 or 1/4? These two are not equal. So that also tells me that they're non-proportional. Remember that they have to be, all their rates have to be equal in order to be proportional. So they are non-proportional because it is not a straight line. It passes through the origin, but it's not a straight line. So it's still not proportional. All right, example 3. Which batting cage represents a proportional relationship between the number of pitches thrown and the cost? So they went ahead and graphed it for us. Looking at these two, what is softball plus? Is it proportional or not? No? Why not? It doesn't go through the origin. So softball plus, it is a straight line, but it does not pass through the origin. So it's not proportional. What about Fun Center?
Yes.
It is, because it does both, right? It passes through the origin, and it's a straight line. Therefore, it is proportional. So it has to be both in order to be proportional. All right, last three problems. It says the cost of a 3D movie ticket is $12 for one ticket, $24 for two, and $36 for three. Determine whether the cost is proportional to the number of tickets by graphing it on the coordinate plane. Okay, so normally I need to draw a table, right? But they already gave me my graph, or my coordinate plane. And just by reading that problem, I can probably go ahead and figure out what my coordinate planes are before, or what my ordered pairs are before making a table, right? Because it already has my x-axis labeled as tickets and my y-axis labeled as cost. So if I read that it says $12 for one ticket, that means that I'm going to go over one ticket and I'm going to go up $12. Right? Yes?
Yes.
So if $24 is the cost for two tickets, that means I'm going over 2 and up 24. And then 3 tickets is 36. And when I graph them together, it indeed passes through the origin, which it doesn't tell me, but it's assumed that if you don't go to the movies, then you don't pay any money, right? So if you don't buy a ticket, then you don't have anything to pay for. So you can assume that you start at 0, 0. So is this proportional or not proportional? Proportional. Why?
Because it's a straight line that goes to the origin.
So how else could I do it if I didn't graph it? How else could I figure it out?
Oh, you can do 1 and 12, 2 and 24, 3 and 36, and simplify it.
Okay, close, but we're going to switch it. So it would be 12 over 1, because it's $12 per one ticket, right? That's our unit rate. And then $24 for 2 tickets, and 36 for 3 tickets. And then once you simplify them, 24 over 2 is what? So 12. This is 12. This is 12 also, right? So I have the same rate. So it means that it's proportional. Okay, number 2. Which line here, the Book Palace or the discount books, which one makes a straight line? The Book Palace. So is that the one that's proportional, or is it discount books? Why is the Book Palace proportional?
Because it's a straight line.
The Book Palace is proportional because it's a straight line through 0, 0. It asks you to explain, so that means you must write straight line through 0, 0. This is my 4th time writing it today. 3rd time writing it today, so you've got to write it too. It says explain. You have to explain why. All right, so what about number 3? How does graphing relationships help you determine whether the relationship is proportional or not? Okay. One more second. Guys, how does graphing relationships help you determine whether it's proportional or not? Nathan? You can tell if it's a straight line and if it goes through the origin. So the graph must be a straight line that passes through 0, 0. All right, the rest of this packet is your homework.